Oh, 2.6 day 2. This is just another example. This is kind of review what your homework should have been, right? It's x-intercept, y-intercept, domain, vertical asymptotes, horizontal asymptotes. So what is the first thing I do on this problem? Factor. Numerator factors to what? What's the numerator factor to? 2 and 1. So x plus 2, x minus 1.
Yep.
Denominator?
2 and 3.
2 and 3. So x minus 3, x plus 2.
Yeah. And then you can take those two out, you can simplify them.
Domain first, right?
Oh, yeah.
Yeah.
3 and negative 2.
So x such that x cannot equal negative 2 and 3. And you did have a few on your homework that were fractions, so make sure you're doing those right. Okay, now I have to reduce. The reason I have to reduce, and I'm going to talk about this, when I do x-intercepts, what part of my function do I set equal to 0? The numerator, okay? When I do vertical asymptotes, what part of it do I set equal to 0? The denominator. Can negative 2 be both an x-intercept and a vertical asymptote?
No.
No, because by definition, if vertical asymptote is something I go towards, right? And then I shoot off to negative infinity or positive infinity. So I cannot have something that is both an x-intercept and a vertical asymptote. It can't happen, can it? Okay, so I have x minus 1 equals 0, so my x-intercept is 1, 0. Remember, write it as a point, because it's a point on a graph.
Yeah.
How do I find the y-intercept?
You said you put zeros in first.
Okay, zeros for anything. And now I can do it at the beginning or the reduced. It doesn't matter. Okay? Reduced would be 0 minus 1 over 0 minus 3. So that would equal 1/3.
Yeah.
So 0 1/3 is my y-intercept. What's next?
Your vertical.
Vertical asymptote. How do I find vertical asymptote?
You said the bottom equal to 0 if you're simplifying equation.
Yes, the simplified. So x minus 3 equals 0. So x equals
3.
3.
Now you're horizontal.
Horizontal. How do I do horizontal?
Compare the exponents of the numerator.
Okay, now you can do again the initial or the reduced. It should not matter.
Like addition.
I like to go back to the initial, but on this one the reduced is fine. The thing is, if I have multiple quantities in the reduced, I'd have to multiply it out, wouldn't I? Like if I had another quantity over here, I'd have to multiply the denominator out, wouldn't I? So it doesn't matter either one, it should come out the same. So let's go back to the original. So 2 and 2. So what's their inequality? Equal. And when they're equal, what do I do?
You compare them. Like
The ratio. The ratio of the leading coefficients. So I have 1 and 1, right? So I get 1. So today what we're going to do is we're going to start this, and we're going to start to here, and then we're going to come over and start placing these on a graph and find the rest of our information. So we have domain is just domain. It has nothing to do with my graph. Okay. Now, if you read the book and the sheet, it says do it and plot it, do it and plot it, do it and plot it. It's just easier to get to about your horizontal asymptote than plot everything at one time. Okay, so I have an x-intercept at 1, 0. So that would be right here. I have a y-intercept at 1/3. Now, I can put a little mark there to know it's 1/3, but I hate to put 1/3 on there because what if I don't go exactly through it? It might be funny, right? I can change it to 1/3 later. Then I have a vertical asymptote at where? 3. So 1, 2, and I put your dotted lines for your asymptotes. That means they're imaginary. Okay. I have a horizontal asymptote at where? 1. Okay, now this has no middle section, so you can just go ahead and put it across the whole thing. Like that one yesterday, I did an example of it. It had a middle section, so I only put it out to the side. So looking at this, I probably should have a fair idea what this looks like. It is a function, it tells me that, yes? So it has to pass the vertical line test, doesn't it? So also, I have to go through x and y intercepts, don't I?
So they go like this?
So it's going to go, and that asymptotes are like magnets. I go closer and closer to them, not far away from them. So it's going to go and then go to negative infinity, isn't it?
That's what I thought.
Okay. Now, is there going to be anything up here?
No.
No, because then it would fail the vertical line test, correct?
Yeah.
So it's not going to be there. Is there going to be anything over here?
No.
Because there's not a what? There's no x-intercept, and I have to get to those asymptotes, don't I? So it has to be where?
The corner.
Right there. But we're going to do something on your list that says next. It says interval analysis, yes? Well, it says plot 1 through 5. That's what we did. And it says perform interval analysis. Okay, so we're going to perform interval analysis on every graph. This one, we could reason our way through it and find it. But we're going to perform it to check our work. So what intervals are, we've done intervals before, and it's all the x-axis, correct? So any interruption in the x-axis, that would mean x-intercepts, vertical asymptotes. Those are the only two things that interrupt the x-intercept, correct? So, picture yourself walking down the x-axis, and what is the first thing you run into that's going to cause an issue?
The x-intercept.
The x-intercept. So, my interval, and I just put int A. What does int A stand for? Interval analysis. Okay? Always start at negative infinity, because that's the furthest left, correct? And go until you hit one of those two things. What were the two things I said?
The
Vertical asymptote,
and the x-intercept.
x-intercept. So the first thing I hit is an x-intercept at 1. And then I leave 1. What is the next interruption I run into? Vertical asymptote at where? 3. And then I leave 3.
Negative infinity.
Positive infinity. So, if I have 1 vertical asymptote and 1 x-intercept, which I do, correct? Think of your x-axis as a string. Okay? I have a string and I cut it twice. How many pieces do I have? 3. 3, because I cut it twice. If I have a string and I had 3 x-intercepts and 2 vertical asymptotes, I'm cutting it 5 times. How many intervals do I have? 6. Okay? So as many times as I cut it, I have 1 more interval. What we do with intervals is test it, whether it's positive or negative. So when I put in an x, I get out a what? A y. And y's, if they're positive, are above the x-axis, yes? And if they're negative, they're below. I don't care the number. Everyone hear me. If you want to do the number, the book does the actual number and plots that specific point. I don't care. I want, is it positive or negative? So what you're going to show me is int A for what? What does that stand for? Interval analysis. These are my intervals, yes? And you're going to show me what number you plug in. So I just need a number between negative infinity and 1. Try not to use 0 because sometimes we do funky things with 0 and do it wrong, okay? But if it's our only option, use it. So what's a number between negative infinity and 1 you'd like to use? Negative 1. Okay. So what I do with this negative 1 is I plug it in here to my reduced function. If I plug in negative 1 to the numerator, do I get a negative or a positive?
Negative.
A negative. If I plug it into the denominator, do I get a negative or a positive? Negative. So a negative divided by a negative is a what?
Positive.
Positive. So between negative infinity and 1, the graph is going to be above the x-axis. Is our graph above the x-axis?
No.
Yes. Now, I didn't say above the horizontal asymptote. I just said above the x-axis, didn't I? Okay. Now, we said between 1 and 3, it better be negative, so let's check it. So I need a number between 1 and 3. 2. So if I plug 2 into the numerator, positive or negative? Positive. 2 into the denominator, negative. So I have a positive divided by negative is a negative. Okay. Now, from reasoning, we've said this next part better be positive, and that positive is going to have to be in that asymptote place, right? So let's check out a number 3 to positive infinity. 4. Not like 780,000.
I'll pass.
Okay. Put 4 into the numerator. What do I get? Positive. 4 into the denominator. What do I get? And the whole thing is positive. And then you connect your curves. We were able to connect our curves by just reasoning through that. But if we would have gotten a negative positive, should we go back and check our work? Yes. I would start with my work I just did in my interval analysis and then go back other places. Maybe I was supposed to have a negative 1 and rather than a positive 1 or something like that. None of this math should be difficult to check, should it? No. As long as you start off factoring correctly, everything else should fall pretty much in place. Okay, XY intercept domain, vertical asymptote, and we're just going to go ahead and graph it. Because I don't know how far we're going to get, so we're just going to graph every one, okay? So I have 4 plus 10 over x squared plus 5. I do not have one rational expression there, do I? I have how many? 2. 4. Is that a rational number? And then I have 10 over x squared plus 5. So I probably don't want to do 2 of them. I want 1. How do I get one thing? 1 over 4 and get common denominators. So I have 1, a 4 over 1, right? So that means I have to multiply 4 by what?
X squared plus 5.
I have to multiply it by x squared plus 5. So that would give me 4x squared plus 20 plus 10, right? All over x squared plus 5. So I have 4x squared plus 30.
Yep.
Can I factor that?
You can take out 2.
I can take out a 2. So I have 2x squared plus 15.
1, 2, 2 and 2x squared plus.
Yes. Thank you. And my denominator is x squared plus 5. Can I reduce anything?
Wait, how'd you get 2x squared plus 15? Where did 20 go?
I have 20 and 10 is 30.
Oh, okay. Never mind.
Can I reduce anything?
No.
Mm-mm. But I still had to do it, right? So domain. Let's leave our domain for a second. X-intercept. You had a problem with the math, didn't you? There's a sticky there. Okay, how do I get my x-intercept?
You said the top of the
Set the
numerator
y
equals
equals
0.
0.
Top. Now, do I have to put the 2 equal to 0? No, because 2 can't equal 0. There's no variable with it, is it? So I have 2x squared plus 15. So that would be subtract 15 and divide by 2. negative 15 halves, so what, the negative 7.5? Right? Okay, y-intercept, 0 for x. So that gives me 2 times 0 plus 15 over 0 plus 5.
Would be 30.
So it'd be 30 over 5,
6.
so 6. Ooh, that's a backwards comma. And then what next?
VA.
VA, what does VA stand for?
Vertical
Vertical
asymptote.
How do I find vertical asymptote? Set your denominator. Again, what we were going to do with our domain, right?
Yeah.
So that would be x squared equals negative 5 square root.
No.
So is there any vertical asymptote?
No.
Why not?
Because you can't have an imaginary number.
It's an imaginary number, right? So there's none, and you just write none. So is there going to be any restrictions on my domain then?
No.
No. So it's what?
All real
All real numbers. Sometimes you just need to do the math and convince yourself of it. So what's next?
HA.
HA, what's HA?
Horizontal asymptote.
Horizontal. How do I find horizontal? Degrees. So it'd be 2 over 2, right? X squared and x squared.
Oh yeah, because it's a reduced version.
Well, it doesn't matter. I'm using
That's what I said. You can't use the very top, like the original.
Oh no, you can't use the original. You can use the combined. We can't the reduced. We're not using the reduced.
Oh,
The factor.
Yeah.
Okay,
My bad.
so 2 equals 2, right? So y equals 4 over 1. So 4. Okay. I wonder if I put this bigger like this. No, it didn't give me any more room, did it? Okay, so I'm going to graph this stuff that I have. Okay, so that's negative 7 halves. So like right there?
Yeah.
Those are really big hash marks. Okay, y-intercept is 6. There's no vertical asymptote. There's a horizontal asymptote at 4. This is causing my brain issues. Why did I put it outside?
There's the middle.
Because there's like a middle area, isn't there? This is really causing me issues. Okay. Int A, right? What's int A?
Interval analysis.
Interval analysis. So always start where?
Negative
Negative
infinity.
infinity.
Negative infinity. What two things make intervals?
X-intercepts and vertical.
X-intercepts and vertical asymptotes.
So you're like
Right.
hitting it once.
So then we go to negative
7.
7.
Yeah, negative 15 halves.
Yeah.
Okay, and then I leave negative 15 halves and go where?
Positive thing.
Positive infinity. Now, the nice thing about this is I don't have to use 15 halves, do I? I just use negative 8 or negative 9, right? Let's use negative 9. Alex, you're good. Okay, so if I plug in negative 9, I get a positive, don't I? Because it's all squared. Everything's squared. Am I ever going to get a negative? No. So I get a positive. Okay, well, if I plug in
Positive 9.
positive 9, I get a what? Positive. This graph is bothering me. Anybody figure out why it's bothering me?
Looks weird.
Well, first of all, I have to go through an x-intercept, don't I?
No, you can't. 'Cause
Oh, shoot. You know what we did on our x-intercept? We messed up.
Do you do it in the simplified version?
Look,
X
we're
squared-
fine, but it's x squared equals negative 15 halves. Yes?
Ah, yeah.
And what do I do with, I have to take the what of both sides? The square root. So is there an x-intercept? No.
Whoa.
Because look at that graph. I have to go through an x-intercept, don't I? And I can't go through an x-intercept and get a graph like that, can I? Because I'd have to go through this x-intercept, but I'd also have to go next to that horizontal asymptote. That can't happen. Now, if the x-intercept was a double and it bounced, could it do it? Yeah, but it's not a double. Well, it's a double imaginary. Okay, so that 0 isn't there. These are in place to check us, guys, to make sure we're doing the graph right. Okay, so now we just have this, don't we?
Yeah.
How would you do
Okay,
that?
so-
into A then?
What?
Would we have to change our interval
Oh,
now?
well, our interval then is just from negative infinity to what?
Positive.
Positive infinity. And we used 9 and got a positive, right?
Yeah.
So we did more work than we needed to do, but we found the same answer, right? So again, asymptotes are like magnets, right?
Yep.
And I have to, so I'm going to come along here and then do what? Jump up, and then what? Go right back down.
Like a weird
Now, how else could I check my work? My calculator. Put this equation in your calculator and put the original. Go clear back to the original in your calculator.
Yeah, same.
So it was 4 plus 10 over x squared plus 5, right? Because I'm going to lose it off my screen. Well, you all have a graphing calculator. That's what you should be putting it into. So y equals clear, clear, and I'm going to put 4 plus, and then I have to put parentheses around my fraction. So 10 divided by, and I have to put parentheses around my denominator, x squared plus 5. Okay, and then I'm going to hit zoom 6. Because if we're right, we still should be able to see it. Did we graph it right? Yeah. So can you always check your graph?
What did you put in again? Just the equation?
X
Just the
squared
equation.
minus 5.
The biggest thing is you need to make sure you put parentheses. And why did I put the original in and not after I simplified it?
Because it's the original equation.
And what if I messed up simplifying it, right? So when you have this, you need to make sure you put parentheses around your numerator and your denominator. Got it?
Yeah.
Because if you do not, it would graph the numerator correctly, but then it would divide by the first term of the denominator and then just do all the rest. It follows order of operations. So if you want it to do the numerator first, the denominator first, then together, you got to tell it to. But use your graphing calculator so you can get used to using it and checking your work, okay? Now, it can't tell me all the other stuff, right?
Because I'm going to tell you, when I grade this test, this problem is probably worth 16 points. The graph is worth 4 out of the 16. So what's more important, your work or your graph? Your work.
Are we gonna be able to use the calculator?
No, we won't.
Be able to check it?
No, you won't be able to check it.
Ready to be great.
Why not?
Because I'm horribly mean. Okay, so this is the next one. We've already done it. Sketch it, do your interval analysis, and go. Okay, we've done it for 2 problems already, right? So this is the sheet. This is a copy of the sheet you have. If you want to make notes on this sheet, I would suggest you make it. I did tell you it says find x-intercept, if any. It says n of x equals 0. What's n of x stand for? Numerator. Okay, set the numerator equals 0. That's already on your sheet. How do I find a y-intercept? Plug in what? 0 for x's. Okay, find your vertical asymptotes. How do I do that?
Set the domain.
Set the denominator equal to 0. Also used for the domain, except for that reduced part, okay? Now, I'm going to go back here real quick. We had, not there, was it the one before it? Okay, we had a -2 that we zeroed out, we got rid of, right? At -2, there is actually a little hole in this graph. Wait, x equals -2, not y. Sorry, don't pay attention to that. There's actually a hole in that graph right there.
What?
Because we can't be -2. It can't be -2, correct? So at -2, there's actually a hole.
Just
Like where the
just
lines
a pothole.
disconnect?
Just a pothole. It's just a pothole. Because it can't be an x-intercept, right? And it can't be a vertical asymptote because it can't be both of those things. So it just does not exist right at this point. So first of all, is this a continuous graph? Can I draw the whole graph without picking up my pencil?
Yeah.
No.
No, because there's a left and a right-hand part,
And there's a hole.
correct? Well, not besides the hole.
Oh, okay.
Okay, it's not a continuous graph.
Yeah, I thought you were just talking about that one.
No,
one,
no, no.
one.
The whole graph as a whole, is it continuous?
No.
No. Now, is the right half continuous? Yes. Is the left half continuous?
No.
No, because it has that little hole. I'm not going to be a stickler on the hole, but you do need to know that it's there. Okay.
So
Okay,
it's a
next
hole
thing.
and it's there.
Okay, then we do horizontal asymptotes, and you might want to, like, at some point when you're going through your homework, put in your rules, because I left some room to do that. Put in your rules. If the degrees equal, what is it? The degrees of the numerator, degrees of the denominator equal.
Oh, then you do the ratio.
You do the ratio. If the degree of the numerator is less than the degree of the denominator,
That makes it. Oh wait,
Then you use the denominator.
no.
And then it's with 0.
Y equals 0. If the degree of the numerator is greater
There's
than
not.
no.
there isn't a horizontal,
That's a slant.
but
There's
not
a
always a
slant.
slant. Not always a slant. Okay, perform interval analysis. What made intervals?
The x-intercept and
X-intercepts and
the vertical asymptote.
vertical asymptotes. And that's after I reduced, guys, after I reduced. Sketch it and state the domain, but we put the domain where? Right up there. Can I do the domain at any time? Yes. But you can move your domain on your sheet. There's room to write it. Okay, this keeps going backwards. Okay. Oh, that one looks too easy. Doesn't that look too easy?
No, I like it.
No?
It's pretty
Okay. First thing, simplify. Check.
good. Simplified.
Check. That's a check.
Supposed to
Then
be.
your
Domain. How do I find domain?
set the
There's
denominator
denominator
equal to
equal to
0.
zero.
So it's x such that x
They're having troubles.
Yeah, I'm having big trouble.
The pen is not doing.
The pen is not and my brain is not. So I'm really doomed today, right?
Not equal to 2?
Normally the penguin is doing more.
Okay, now what?
You
Your
gotta do your
x-intercepts.
x-intercepts.
Okay, how do I
Set
find?
the numerator to 0.
Okay, make sure you're labeling your work, right?
Yep, so there's that.
So 3 equals 0. 3
You have
equals
to put it
0?
as a point.
No.
Does 3 equal 0?
No,
No.
you can't do that.
No. So I do that and I write
None.
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 I showed my work and I said none, right?
And
Not a whole lot of individual parts have a lot of work, right? Okay, y-intercept.
you put a 0 back in for
0 is for x. So I get 3 over 0 minus 2.
Negative 2.
So I get
negative
0,
3 half.
negative 3 halves.
vertical asymptote.
Okay, how do I find vertical asymptotes?
Set the bottom equal to 0.
So that's x minus 2 equals 0?
Yeah.
So
So
x
2.
equals?
X equals 2. Horizontal.
Horizontal.
How do I do horizontal?
The
The degrees. What's the degree of the numerator?
1.
0. What's the degree of the denominator? 1. So my inequality is?
0.
Oh, 1 is
No.
greater than 0.
Wait, so
None.
1, 0.
Is
Well,
less
say
than
it
1.
this way.
Oh,
Okay,
0
I
is
use
less
it.
than 1.
0 is less than 1. That's what I was trying to get. Okay, so numerator is less than denominator. I always have to put it numerator, denominator, because that's how I compare them, correct?
Yeah.
Okay, so the numerator is less than, so it's y equals 0. And that's just what the rule says, right? So am I ready to put that stuff on a graph? Yep. And I will take off if these arrows on the positive x and positive y are not there. If it's a big plus sign, we don't graph on big plus signs, do we?
I love the graph
Okay.
on big plus signs.
No x-intercept. That's easy. Our y-intercept is negative 1.5, so,
Negative.
right? Negative 3 halves is negative 1.5. Okay, and then vertical asymptote is at
2.
2.
And the next one is on your x-axis.
And when I do there, it's just kind of slant it. And why did I go across the whole thing? Because there's no middle section, is there?
How do you tell if there's a middle?
Like if you had another vertical asymptote, you'd have a middle section. Okay, and you don't have to. You can just put it on the very ends if you want. But sometimes I just think it's easier. So what's our interval going to be?
Negative infinity to positive infinity. No, negative infinity.
Negative infinity to
2.
2.
Then 2 to positive.
Then 2 to positive infinity. Because where do these come from? X-intercepts and
Vertical asymptote.
vertical asymptotes. Okay, so negative infinity to 2.
1.
1. And all I care about is, I do want to know what you plug in, guys. Really, I do. Because sometimes when we get fractions, our brain like twists things up. Don't use a fraction unless you absolutely have to. But remember, the nice thing is I don't care what the answer, the number answer is. I just care what the sign is, right? And we usually can tell if a fraction's bigger or smaller than a positive, correct?
Where do you get the 1 from?
It's just any number between negative infinity and 2.
Okay.
We could have used negative 20,000 if we wanted. Okay, so
Put
1,
in the original equation.
original equation, because that's how we got, right? So the top is going to be positive regardless, because there's no variable, correct? The bottom's going to be what?
Bottom's gonna be negative.
Negative. So the whole thing is negative. So down here. Well, we almost should have known that because we have a y-intercept and we have to go through it, correct?
So it'll be like this. On that line.
So it's going to be
Make it over down.
like that, yes?
Yeah.
Always at a vertical asymptote, the graph either goes to positive infinity or negative infinity. Always at a vertical asymptote. It doesn't just stop. Can't happen. Okay, 2 to positive infinity. Gentry, give me a number from 2 to positive infinity. 3. Oh boy.
Being real
Sorry.
creative. on
Okay,
that.
so my numerator is
Three.
positive. Okay, because there's nothing there to change it, correct? And the denominator is
Positive.
positive.
So it's gonna be in the top right corner.
It's going to be in the top right corner. Now, could it have been down here?
Yeah.
Yeah, because you're limited. I mean, you could have been down there, but this one is not. So do you see how we sometimes have to?
Yes.
Now, I'm going to tell you right now, I'm fixing my line. If your line looks like, I'll have people do this, and they'll go like this. Is that wrong?
Yeah.
Yes, because that asymptote pulls it in. If your lines don't look like it's pulling into that asymptote, I will take off some pretty points. So, should you, if you practice this with all these problems, should there be a problem knowing what's going to happen?
No.
No. This is the test, guys. We will learn nothing new.
What about
This is it.
slant?
Oh, slant. We'll learn slant.
That's
But
it.
So
other than
this is
slant,
slant.
this is it.
This is the whole
This is
test.
This is it.
How
Easy
many
goes.
problems are there like this?
On the test, there are 6.
It's a
Like
6
that.
question test.
Well, no, not just like you're gonna have ones that you have to like factor and
Okay, so
Okay.
if you miss,
okay. So let's get to a better one. Why do I say let's get to a better one?
It's
You
simple.
can't really
Because
do
there's nothing we don't have to, you know.
You can
Factor.
Our x-intercept's gonna be -3/2, but other than that, there's not really anything, right? Let's get one we need to factor. How about that?
right there.
Oh,
Ooh, okay.
that's messy.
Ooh, that's pretty.
Ah.
Okay.
Wait a minute.
3 times 4 is 12 and
3 times 4 is 12.
so 6 and 2.
6 and 2?
Yep.
Okay, so I know it's going to be 3x, right? And
Yup.
x. So I need 6, so that has to be 2. And I need 4, so that has to be 2. And they're both negative? Now do you know why we've been practicing factoring so much?
I don't like
I'm not
that.
good
That's
at
literally what this whole class
It
is
takes
consistent.
me forever. Like it takes me.
Okay, so this week, because our test is next Thursday, so this week you really need to be focusing on your factoring because if that's your biggest problem, right? You really need to be focusing on your factoring. Okay, we got 2 minutes, so let's go. What's next? 2 times 2 is 4. 4. So I need 4 and 1. So 2x and x. So this has to be a 2, right?
Yeah, another one has to be.
And that one has to be negative, and this one has to be positive?
Yeah.
Oops, how about a 1?
Wait. So what does that equal? -3?
Yes. So 2 times -2 is -4.
Oh,
Okay. Anything reduce? Oh wait, Dwayne. X such that x is not equal to what?
okay.
Negative 1/2 and 2. Now reduce. After you do domain, get it out of there and don't touch it again. Got it? Okay, x-intercepts. 2x. No, 3x. minus 2. So negative 2/3.
Wait.
No, it'd be positive.
It'd be
It'd be
positive.
positive 2/3.
Adding over.
Okay. Y-intercept. Reduced. This
Yeah.
time would reduce would be
2
nice.
over -2.
So -2, so it'd be 0 minus 2 over 0 plus 1, so it is,
-2.
so 2, negative
So it'd
2,
be -2.
so 0, -2.
BA.
BA is what? Denominator.
Set equal to 0.
So x equals negative 1/2. HA, either numerator or denominator, but it's 2 equals 2. So y equals 3/2. My interval analysis is negative infinity to what?
Negative infinity to
Negative 1/2.
negative 1/2.
I should have graphed it. You see how graphing it makes it easier to do
Yeah,
this?
because you can tell which is what is what.
And then
which
negative
one's
1/2 to
0.
No.
What? No.
Negative one
Negative,
half to
yeah,
2/3.
2/3
And then 2/3.
and 2/3
to
to
positive
Positive.
infinity.
positive infinity.
Yeah,
And you
graphing it
something
makes
in
it so
the-
you can see it better.
Graphing, that's why we graph this stuff first. Okay? And obviously you're going to use 0 on this one, yes?
Yeah.
Okay. But after I factor it, is it pretty much
Yeah.
Okay. So do your homework tonight so we can answer questions tomorrow and practice because there's other than slant.